Okay, so we're going to take a look at this problem here. We'll start first with the part modeling, and then we'll take a look at part 2, developing the drawing. As you can see, we've got a section view together with a detailed view. Let's go ahead and start with the part modeling. We're going to be using the imperial decimal units. One way to look at this is if we look at the top view here, we could certainly set up the base extrude sketch centered on the origin and use some mirrored sketch entities to create the profile and the hole, which we can extrude as the base. Then we could use our legacy hole wizard for the counterbore, and then finally finish with our chamfered edge. And then we can take a look at developing the drawing. So why don't we start with the model first and go ahead to our SolidWorks here, and we'll just start with a basic part template. And one of the first things we want to do here is let's just take a look at our units. I'm just going to use the basic inch, pound, second. Okay. And since we talked about using the top plane first, let's go ahead and select the top plane and start a new sketch there. Also, I want to make sure that I can see my origin, because I'll center everything there. And we'll start with some center lines. Just going to project away from the origin there, create a horizontal line going through the origin, and then we'll do another center line that's going to be vertical passing through the origin. Alright, and as we continue with sketching, this is where I can try to use some dynamic mirror to create our layout here. So first of all, let's start with some radii. We got the center radius here, which I'm going to start at the origin, and I'm going to set that at 150. Alright, you can see it started with a diameter, but if I just click out of this, select that dimension, right click, and then display it as a radius. Actually, you can see here it says diameter again, so I'll do it like this, right click again, and now you should see radius. It's a little bit cumbersome, but there it is. We'll do radius, and this should be 150. Alright, and then next to that we'll do another radius. Again, I'm just starting with the base extrusion profile, which is 0.62. Okay, so I'm going to start coincident here on this horizontal construction line. Let's start again with circle, start coincident there, and then use smart dimension. Again, you can see how it went into diameter. I'm just going to right click there, show it as a radius, and this should be 0.62. Alright, now the other thing is I also want to set the distance correctly, right? And it should be at 195. So I'm going to select the center here, and select the center of this circle, and then place that at 1.95. Okay. So basically I have 1/2 here, and I can continue sketching out the rest. But what I'm going to do is do the sides here first. So I'm going to select that horizontal construction line and then activate my dynamic mirror. Now I'm doing this so I could do the bottom half. Okay, and I'll go like this. Start with line. First, I'm just going to draw a line. Then I'm going to use relations. Okay, so I'm just going to exit the line command there. I've got one line selected, and then I'll control click one of the circles. And you can see here we can add a relation, right? So let me try this again. Let's try the line and then control click the circle there. We should be able to select tangent. Deselect just by clicking anywhere in the drawing area. Again, reselect the line, control click the second circle, and then again use add relation. So you can see, because I still have dynamic mirror, the bottom half is also adjusting. Alright, now before I do the other side, I'm just going to trim up the line work here to make it easier to mirror to the other side. So I'm going to use my trim extend command here. Just trim off the excess, and then on the inside as well. All right, we got that. Now, using our center reference line here, we're going to use mirror entities. So the entities to mirror are going to be the line here, the arc, and the line down here. And for our mirror axis, we're going to use that vertical construction line there. And then click OK. I'll use Fit to zoom out. And then now we have just a couple more trims to make. So this would be the base profile, right? Now at the same time, we can create the hole, the two side holes there, which is a diameter of 0.74, and it's also 0.19 from the center there. So we could actually make it concentric with this arc. Now, what I'm going to do is I'm going to select the vertical construction line here, and you'll notice we're going to turn on the dynamic mirror once again, and I'm going to come over here to circle. I'm going to sketch the circle. First, I'm going to hover over the arc so I can detect the center there, place it, and then we'll dimension it. And that should be a diameter, using Smart Dimension here, a diameter of 0.74. Okay, and we can see we have equal sized sketch circle on the other side and same distance. Okay, now this is the base profile, so what we want to do now is we want to extrude it its full height, which is going to be 0.74. So we're going to switch over to features and do the extrude boss and just do a blind 0.74 extrusion. Okay, so you can see closed profiles within closed profiles on extrusion will create the hole. Now, if we take a look at the drawing, we can see that that center hole is actually a counterbore. And you can see here, based on the detail view, the section view here, and the top view, we have the dimensions needed. So we have the counterbore diameter, which is 250, the cut hole diameter of 2, and we have there a counterbore depth of 0.74 minus 0.35. We'll have to do a little bit of math, but no problem. I'm going to start with the top face here. And in order to position my counterbore correctly, one thing I could do is I could create a reference sketch and find the center, right? I could also just simply use the hole wizard and use dimensioning to position the whole location point. Let's go ahead and do that. All right. So if I start with hole wizard, first thing I want to do is take a look at the type tab and take a look at hole type. You can see here I have legacy hole selected. If you look just below that in the drop down menu, we're going to select the counterboard hole type, and then just below that you'll see here, let's just compact this here. You'll see, well actually it'd be good just to see the profile there, but you'll see here in the section dimensions you'll have the diameter, the depth, the counterbore diameter, and the counterbore depth. So we know for our counterbore diameter, and that's the larger diameter, that's going to be a diameter of 250. And then below here you can see the counterbore depth. Now we don't have the actual depth, but what we have is 0.74 minus 0.35. And that should give us our counterbore depth, right? And actually, don't know if that's going to work there for us in the value box, but we could certainly just use our calc. So we'll just go ahead and just enter the value there, 0.39. Okay, now if you look here at diameter, this is going to be the hole through, which is going to be a diameter of 2. And I'm not going to worry about the depth, because you can see down here in the end condition, we're just going to do through all. So these are the settings for the profile for the counterbore. And now if we go to the positions tab, now you'll notice that we can just place it, right? Keep in mind that we use the origin, right? The origin as the central organizing feature. So we can easily just select the origin there. However, if we don't have something like this that we could snap to, notice that if I just place it, okay, and then if I use a right click and use select, I can still select that point and then create a relation or use dimension, smart dimension, to actually position it correctly. All right? So I just put it off to the side, and then I just manually created the coincidence with the origin there. Click OK, and now you can see our counterbore. All right. To finish off the modeling here, we got to do a 0.12 45-degree chamfer. All right. And we could easily select the face to do the chamfer, but we don't want to do all of the edges. We just want to do the outer edge here. And if we select one part of the edge and then right-click right over it, you can see you can select loop. Okay. Now notice that the outer loop, highlighted blue, is the actual loop that we want. So be careful when you select an edge and what loop you actually select as a result. And what we'll do here is we'll select our chamfer command, and here you can see we've got 0.12, okay, and we got 45 degrees. Now notice we have tangent propagation, right? We got the whole loop there, so it should go all the way around. We could do a full preview if we like, if we need to make adjustments, and then click OK to finalize the part. Now that we got the part, now we can actually do our part drawing. So before we do that, go ahead and save it, and then we'll start a new drawing.